Hello everyone, my name is Vander Kolki and welcome to the today tutorial. Today we're going to go through basically the Mold Wizard using a Siemens NX. I'm going to explore basically how we would be able to actually use the Mold Wizard from the Siemens NX. So let's begin together. What I want you to do, please go and open your browser. Go to your Canvas page for the module of ME7722. And you need to select the topic 1, the CAD surface modeling. Please click on CAD surface modeling in here and please scroll down, and if you're new to the world of Siemens NX, you can click on the unit 1.1, which basically will get access to all of my pre-recorded videos that I basically had, including the 2D modeling, the 3D modeling, the assembly and technical drawing. But for today we're going to concentrate onto the unit 1.3, which is a mold design and validation. Please click on mold design and validation and scroll down and you'll see a tutorial 1. So you will see the tutorial file for this tutorial, which you'll go through today, and this is what we are going through by today's session. But in order to do that, I want you to download the tutorial 1 file, please. I'm going to click on download and I'm going to download it. So click under the folder where it saved the file. So I'm going to click on that to be able to actually see the file. And now I'm going to click and open up the file. Once you open up the file, it's really important actually we create a new folder, because you will see we start with one file, but we're going to use the different files. I'm going to put A7722, let's say tutorial 1, and I'm going to make sure I move this file and put it there. You will see we're going to start with one file, but now we're going to generate few files once we work with the basically Mold Wizard. So now let's launch the Siemens NX, open the apps anywhere, and either search for Siemens NX, or if you already favorite you have it, make sure you basically run the latest version of the NX that we have. So I'm going to run the latest version and I'm going to let the software to initiate the apps anywhere using the cloud paging. I'm going to give it some time so the app would be able to basically be opened. So you need to give some time to make sure the NX open. Also you need to give some time to all the packages of NX also load as well. So Siemens NX has now been opened, and please click on open, and please go and load the file that basically you downloaded. In my case, it's in my folder, download in the folder I created, and this is the model that I have, and I'm going to load. I'm going to make sure it's a .prt, which is the part extension for NX. I'm going to click OK. I'm going to let the software to open it up. So what you will see that we are into the modeling environment. Into the modeling environment, you will see the modeling features, the 2D and 3D features. And what I need to do, I need to make sure that actually I rotate the coordination system for my model. So in order to do that, what I will do, I will double click on the coordination system. I will hold the scroll into the mouse to rotate the model. And what I will do, I'm gonna bring the Z up. So what I will do, I will bring the Z up, and then what I need to do, I need to save the file by using the Control S or click on the save to make sure you save the file. So this is quite an important stage for this particular file, not all the time, because otherwise once you bring the core and cavity, it become in opposite direction. That's the first stage what we need for this specific part, but doesn't necessary for every single part that you need to do. You need to update it. You just need to make sure that Z is in the positive direction. So once you do that, now we need to start the Mold Wizard. Please go to the application, and the beauty of NX, it has a different basically sub packages. You can do the modeling with it, you can do the manufacturing, computed manufacturing, you do a FEA analysis. For today we're going to use Mold. Depends on whether your company you're going to work with has the Mold Wizard or not. Sometimes you don't see that feature. I'm going to click on Mold, which is a separate package, and you will see it takes some time to bring that Mold package, and the user interface and the toolbar will change. What I need to do, I need to initialize the basically this Mold Wizard, and the beauty of that, you will see It gives you a step-by-step what you need to do. The first step, initialize project, do the parts validation, do the mold design basically, and bring the mold library, and also then do the validation at the end and see the simulation. I'm gonna start with the initializing the project. You need to make sure it basically direct to the path that you created the folder in. You need to select the material. Let's say in this case it's going to be the ABS, for instance, and I'm going to click OK. Have a look at it. We started with one file, but now it's going to start creating the new files for me, and that's the beauty of the Mold Wizard. It's going to create all the files that are required to be able to actually do the mold design analysis and the simulation. Once you do that, please click on File, please click on a Save, and make sure you click on Save All, because it generates few files that needs to be saved. So now to just show you, if you click on the folder, you will see that we started with this file, but now we have all these files, all the 25 files has been generated, which is why I ask you to actually save it in the folder, otherwise it's going to be all over the place. So now, again, you will see the coordination problem, like before. Double click on that, and then make sure that you rotate the model, and I will save it. What is important, make sure that in this stage you are into the top far. Into the top part, you can see the 000. You don't necessarily always get the same number, but if you download the same file, you follow it, you should get the same number, but what is important is it should be in the top file. So into the top file, I'm gonna validate my model to make sure, can I proceed with the mold design or not? In order to do that, into the part validation, click into the mold design validation, select the mold part quality, make sure you stick, and make sure you click on execute checkmate. You're gonna give it some time, you're gonna analyze the model and click on close. But you will see it reveals some draft angles, and hopefully in the lectures, remember those lecture notes, draft angles are quite important because once we finish, we're gonna take the part out. And in here, it raised few issues for me. But you will see the angle is a bit bigger than basically 0, or smaller than 0, because it's the opposite direction technically. They are fine, but areas that I have a perpendicular 90 degree, or in this case 0 degree, these are where I will end up by having issues, so I won't be able to pick up the part. And these 24 areas has been basically raised as a concern to me. So what I need to do, I need to update the model to be able to proceed. What I'm gonna do now, I'm gonna go move from the Mold Wizard to the home, which brings the modeling environment. As I said, you don't have to do it for all the time. If you have a really good design, you don't have to update it, but just get some sort of experience. What I'm gonna do now, I'm gonna go and rotate the model to have a look at those areas that basically cause problem for me. Okay, so I'm gonna go and start thinking what I need to do. So probably what I can do for the back, the draft angles cause the problem. Those draft angles that cause the problem, these areas, right? So what I'm gonna do now, I'm gonna apply basically a draft to change the draft. What I'm gonna do, I'm gonna make sure this one is a no selection, is the entire assembly. I will click onto the draft, and within the draft, what I need to do, I'm gonna apply a draft on the edge, adjust the edge. So we'll click on the edge, and I don't need to worry about the vector yet. I will just select the area. I'm gonna keep it as a stationary, and for that, what I will do, I will basically select the edge that I have in here. So I'm gonna take entire assembly, select the edge, make sure you select the edge correctly, and once I select the edge, I gotta put the cut it short, let's say 1.5 degrees. Yeah, I think I need to change the direction of that, otherwise it wouldn't work. So you can see this is what basically are doing. Do you see the underneath? And if I look into the top view, this is what you're trying to change. So just, yeah, minus 1.5 I think should be fine. Yes, minus 1. This is this one. I'm gonna repeat the same things into the other side as well. Let me bring the model inside. I'm gonna repeat the same things. I click on draft, make sure it's an edge. In the edge, I'm gonna select this edge, Let me move around with the degree so it knows it should be negative minus 1.5 and okay. So these two we're fine. Let's actually go through the other side as well. This time I don't use edge, I gonna use the draft body. Let's go to the more. I'm gonna click on draft body and yes, let's go with the face. I don't mind. This is, I think, would be the parting object that I'm gonna have. It would be the basically the back area. So that's the parting object. Vector would be automatically select, and the face that I'm gonna apply the basically draft gonna be this one. So let's see, 1.5 again. Let's explore. I think 1.5 somehow touched the side. Let's do 1.3. Yes, 1.3 is okay, good. I need to repeat it for the other part as well. I could do it at the same time, but to just clearly show it to you, I prefer to do it separately. So more, draft body we said, the parting lines at the back, the face you're gonna do these, 1.3 and okay. And now I will save. And if I go to the Mold Wizard, and if I basically check again, the mold part quality, checkmate. And then if I basically now have a look at it in here, the issues that was 24 and now is a 22, right? So we basically remove some of those basically problems. So we improve them. And so these are one of the techniques, but bear in mind, you as a designer, you will basically make sure you don't have any 0 degree. So there was a kind of extra step that we had to do. So once you're happy with this stage, you're gonna now, let's do some sort of analysis in terms of the wall thickness. So I'm gonna click on here, the wall thickness. What is important in this stage, you have to be in the molding 0 to 1. Otherwise, you will get basically, you don't get the correct information. In order to move, make sure you file, first save and save all. Make sure you save everything. So either should be in the top file 000 or basically should be in the molding 0 to 1. I'm gonna go to view, I'm gonna go to window, and I'm gonna click on change display part. And as I said, the numbers is not important. The basically the kind of file we're dealing with become quite important. And in here, I'm gonna go with a top part, which is a 0001 basically, or whatever you see, a kind of like a top part, to make sure it's you don't get error. So I'm gonna go with the molding one. And I'm gonna click OK. You can see that the part will change. I'm gonna open up the molding one. If in case you see something like this, don't panic. It's a graphical card error. Click on the refresh first, and then put in the isometric or trimetric, and then reveal the basic model. That's the bug that NX has. So double click on this one. Like before, we're gonna bring the Z up again. I think the designer didn't spend time to update the model. Okay. And what I will do then, I'm gonna go and study the wall thickness in the volume, the Mold Wizard. I'm gonna click on this, and I'm gonna calculate the thickness. And the software now they're gonna reveal the area that they have a thick wall, the area that has a thin wall, and that's important for me. I'm gonna do it one more time. So execute it. You need to give some time. This is a process. So basically, it reveals the wall thickness as far as you can see. We have quite a thick area at the back, and that become quite important because you've done it with the wall thickness is quite important. Whenever it is thick, the cooling time become increased. You get some sort of the warping distortion. Some area might sink. You get defects basically. If you have a thin walls on the other hand, you will have a weaker structure. You might have a poor surface finish. You might have the ejection difficulty as well. So you have to balance it. This is what basically this stage is revealing for us. This is fine. Let's say do the flow analysis. Flow analysis is really important as well. In order to do a flow analysis, click on this one. If you're in case downloaded NX and you're going to run the flow analysis, most probably you don't run on your computer unless you use the Java script and download the Java, which is a separate package. So I'm gonna click where I'm gonna have my gate points. I can have it here, I can have it in the front, I can have it on the side, but most good places either here or here to bring the flow. And we'll have a basically consistent distribution among the model. I'm gonna put in the front. I'm gonna click OK. That process takes some time because it's gonna do analysis. You can see a separate package gonna pop up, which is the Moulding 3D analysis, and I'm gonna click on Analyze now. It takes some time until it will basically fill in and show us or reveal the analysis basically for us. You can see the process is quite slow, so you have to give it some time. So once the simulation is finished, I'm gonna click on OK. And if I click on here, it will be able to actually display that for me. So if I click on play, you will see that how the flow would distribute it. I can control the speed of that. Let me actually bring the speed a little bit down. So you will see that basically how the flow distributes. That shows me in terms of the timing. If I go here, I can see the air traps. So you have to prevent air traps. This basically is really useful tool to see whether when I have defects. I can control the contribution that it will get. You will be able to control the pressure drops, so you should avoid the pressure drops. You can actually get the information about the melting temperatures with the maximum temperature you have across in different areas. Whenever there is thin, the temperature goes up. You can actually find information about the frozen layers. You can see the maximum cooling time. So you can see that the area that they're thicker, like this area, we make them thicker, right? To give that draft angle, it takes more time to fill that area as well. So all of these analyses become quite important. So these are basically the steps for the analysis. Once you're happy with your file, you basically proceed. If not, you will go back, update the part, like what we've done, until you're confident with these. So that's the first stage. Now, in order to proceed, this is really important. We need to make sure we are into the top part. We are not into the top part, we are in molding right now. Like before, go to the view, window, change display part, and make sure you are into the top part. Click these and click OK. The beauty of this, there's multiple basically parts now is open and I keep moving between them. So into the top part, what I need to do, I need to basically bring the coordination system to the center because now we're gonna make a workspace. In order to do that, make sure into the Mold Wizard, and I'm gonna click on this coordination system, which is a mold coordination system. And I'm gonna bring it to the center, and I'm gonna make sure to lock it the Z axis, and I'm gonna select, let's say here. So you can see, bring the coordination system in here and put it exactly in the center. You can either select this one or the back, doesn't matter. But make sure you lock the Z axis, and I'm gonna click on OK. So what it does, it brings the coordination system into the middle, and the Z is to the top. So let's make sure actually before we move on, we're gonna save everything else. So we're gonna save all. And now you need to go to the next step. So I need to make the workpiece. In order to make the workpiece, I'm gonna click on creating a workpiece in here. I'm gonna select this one, and I'm gonna make the workpiece out of. So once you click basically onto the creating workspace, gonna give it some time. So you're gonna open up the model, and what you would be able to do, you would be able to do basically creating the workspace. What is important in here, because my computer crashed now, I had to reopen it again. The coordination system, if it's not in the middle, this is where you get the problem, which is why I said it's really important that coordination system, while you're into the top part, you need to bring these into the basically the center and make sure the Z is locked. I'm gonna put it in here. So, and now have a look at it. If I open it up, then this one goes in the center of that, and that's really important. So what I need to do, I need to make sure the workspace is bigger than the geometry. These are fine, but if in case I wanted to play with any of these, I can basically double click and change the dimensions. If I want to move any of those, I don't want to change it. I think everything is fine because the model is in the middle. So I don't need to change anything else, and I'm gonna click on OK. So basically it created my workpiece, and if I go with let's say wireframe, you will see the model is inside. Let's make the two of that to increase the efficiency. In order to do it, I can click on here, the cavity layout, and with the cavity layout, I can say I want the two of them overall without any gap, and I'm gonna have them in front of each other. So they will have in front of each other, and what I will do, I will just click on OK. So we'll click on close. And basically we end up by having the two cavity. Of course, in here, if I right click, if I go to the edit display and bring down the basically transparency of them, I can see that there are two components, they're all inside. Once we finish, again, file, save all. And also we are still into the top 000. I'm going to define the current cavity. In order to do that, I'm going to move from here basically to here, and I'm going to go with the parting tools. The first option I have here is checking the regions, and I need to check the regions. Again, what you will see that the coordination system is not fine. I'm going to quickly update it. It's okay, and then I will click it one more time on this, and you don't need to touch anything. Just click on calculate. The calculate, they're going to reveal the part for us, and then it will color them, and click on OK. So this one, just check that first. I'm going to do it one more time. I'm going to calculate it. Now go to the region. In the region, I want to say the cavity going to be orange and the core going to be blue, and I'm going to then say click on basically the areas that he wants to move over. So I know for 94 of them are going to be 94 faces going to be in the cavity, 59 with the core region. And what I'm going to do, I'm going to basically click on apply, and here, and click on set regions color now, and click apply. See, the beauty of that, it automatically recognizes which one should be the cavity, which one should be the core. It's not always the case. Sometimes you might have some basically faces being incorrect. Let's have a look at it. Let's say here, instead of being cavity, it was core. What I can do, I can basically go to the face, I can select that face, right? And I say I'm gonna want it to have it as a core. If I click on apply, let me actually do it in here for you. I'm gonna apply on the core, set region, apply. You will see it become blue. So if in case the computer wrongly done it for you, you can do it. I'm gonna bring it back to the core again. So all I will do, I will click the core, or click the cavity, select the plane that I want to move, or the face, sorry, not the plane, the face I want to move, click on a set region color, and click on apply. It will change that. So whenever you have quite a complex model with the bordered faces between the cavity and core, this is the situation that you need to update the model. Otherwise, it should be automatic. So setting the region's color should be automatic and should be fine. So that's one stage that we need to basically go. So, and which was in the basically check-in region. After that, we need to patch the surface. In order to do it, I want you to click basically on the patching the surface. The two areas that are gonna patch, I gonna go and select this one to the body, and I will select this is the body, define two loops for me, and they are in here. I prefer usually to change the color so I can see it. I will open this one up, and I'm gonna change the color to, let's say, green, and I will click on apply. So you'll see those areas become green for me, so I can have a look at it better to them now. Now let's define the regions. I'm gonna click on here, which says define region. You have the cavity and core. Make sure that you don't have any other area which is not defined. If you have an area that is still missing, go back when you apply the set regions, make sure you set them correctly. I'm gonna let the computer automatically create the regions and parting lines for myself, and I don't need to do anything else. I'm gonna go with all faces, and I'll click on apply. So you're gonna basically create those regions for me, and we'll cancel this. So I'll repeat it again. So in here, all faces, create regions, create parting lines. If the faces didn't automatically select it for you, will select, but in this case, basically everything has been clearly chosen, so I don't need to do anything else. And once I finish, I'm gonna click OK. So yeah, I already done that, so it asks you that you already done it. This is this stage. What I need, and you're gonna make the parting surface. In order to go to the parting surface, I'm gonna click on this one, and these are different bays. If you're gonna use automatic, the automatic one is automatic cuts, and you're gonna separate them. You just need to make sure this one is big and bigger than the space that you created for Workspace, so you can extend the sizes in here. It just needs to be bigger than that. But if you have a basically complex part, you need to basically go with extended sheet. You will be able to use the ribbon surface, especially if you have any curved area, and you will be able to also use the guided extension. So if you think the computer wouldn't be able to pick it up, you go with the guided extensions in here. So I'm gonna click on OK. So basically this one cuts the workpiece in the half, and now I'm gonna go and define the current cavity that I have, and now I start working on them. So what I'm gonna do, I'm gonna go and proceed to the next step, which is the defining the core and cavity, and start designing it. So what I will do, I will click in here, and I'm gonna select the all regions in here. Let's start with let's go with the cavity first. I'm gonna click on OK. And so this is really important. We're gonna make sure that this one is, I see whether it needs to be reversed or not. No, it was correct. It was correct location. Yes. And I will click on OK. And then I will do it one more time for the other part. If you click all regions, the beauty of that, it does both of them together. Let's actually see it. So you'll see that you will do the core, but of course you can go with the reverse if in case that you need to modify it. Okay, and this one you're gonna have it with these, which is absolutely right. And okay, so we also define the core and cavity in this system. Go to the top 000 again, the one that we created, because this is in the partings, we don't need it now. Go to this one, and now let's do a simple simulation in here to see how we would be able to actually mount the part. I'm gonna go to the Mold Wizard in here, and I'm gonna go with basically running a simulation. And in order to do that, I need to go and pre-process that simulation. The beauty of that simulation, I'm gonna tell you that you need to put dimensions, so how basically the A should be, and also what we did a D in this case. For the A, I'm gonna come up with some values. It doesn't matter, it should be bigger enough so I can basically take the part out. And what I will do in here, I'm gonna put A 15 for now, and D, I'm gonna put it as the 100. I'm gonna click on OK. I didn't mount anything yet, but to just show you, if I run the simulation now, you will see if I click on play, nothing will happen because the software doesn't know the workpiece, doesn't know the basically core and cavities. So what I will do, I will go to the basically the pre-process motion. I move from add kinematic to the mount components. I'm gonna say which one gonna move, which one gonna be basically a stationary. So let's say with the move, it's gonna be these two, and the fix gonna be these two. So, but there is no basically part in here, so I'm gonna click mount. Fix gonna be mount. I'm gonna click OK, and now if I run the simulation, you will see I have those, but there is no part coming out of the model, right? Because I didn't mount the components yet. So what I need to do basically, I need to, let me do it again. So you will see basically no parts coming out, right? And what I will do into the basically moving element, into the moving one, I need to add a product. So the product that we have in here is not clear. What I need to do, I need to select those products. So it's quite hard to see them. What you can do, you can actually go close this one. I'm gonna close this. I'm gonna click here, hide it, hide this one, go back here, select the product, and the product gonna be this one, mount, click OK. I need to bring everything back. In order to bring everything back, click on show and hide, and I'm gonna bring everything back in here. Click show all, close. Now let's run the simulation. you'll see they basically do the simulation and take the model out. The A probably needs an update. I'm gonna go to the A. I need to make it more, and this one I'm gonna give 100. With the distance for this one I'm gonna give 200 for instance. Click OK, and let's run the simulation now. Which is quite nice. If you want to even save this, you would be able to actually even we would be able to do collision analysis, and you would be able to control the speed of these as well. And it's a really good representation of how the simulation gonna work basically. If you want to record it, by the way, the software has into the tooling area, you would be able to see a record option. So you record your basically screen if you want to save it, or of course you can use a screen capture. So that was it for this part of the tutorial, and that's the tutorial 1. And now we're going to proceed with the tutorial 2, which basically we're going to bring the mold based library. So before I proceed, I'm going to make sure I save everything. Save and save all. And we're going to bring the basically mold based library. So if you go to the Mold Wizard, we've done this part. We've done this part, and now we're going to concentrate on bringing basically the library, which is from these, the two sides. So in order to bring the library, I'm going to click on this one, mold-based library, and with different types. We have so you can see all those types in here, and if I see the preview, you will see this is a 2 A1. I'm going to go and select the 2B, for instance. You can see the 2B. So it's quite a good and complete library in here. I'm gonna go and use the 2A for this activity. You can change the dimension of these if you want, and you can see that actually which dimension it is referring to. You can select on these and change them. I don't want to change it. I just want to bring everything which is default, but from the 2A in here. So I'm gonna give it some time. It's gonna open up all the files in here because it's assembly technically. And automatically bring them, and the beauty of it, automatically also assembled the workspace that we have in terms of even our core and cavity, which is quite useful, and which is why the mold wizard are quite good as well. What you will notice in here, the workspace is not in the center, because when I created the two of them, I didn't auto center them. If you haven't done it, that's fine, don't panic. What you can do, you can go here when you create the cavity, open this extension up and click on auto center. What it does, it brings it into the middle, and that's really important because otherwise it's outside the model. But this is if you have to, otherwise you don't have that problem. So what I'm gonna do, I'm gonna basically bring in the location pin, and the location pin is this one. I'm gonna bring the libraries, which in the library I'll get access to all of those. Make sure you open up the preview and the member select. Otherwise you don't see these two. And there are the different locating ring. I'm gonna bring, let's say, this one. You can change the dimension of that if you want. If you're happy, click on OK. And again, what you will see, they automatically create that model based on the dimension that you set from the library, but also they apply it into the model as well. Of course, add the material. And you can see it goes there, which is why this software is quite powerful, because they use parameters. They parameterize everything so they can resize the model. We bring the location pin. Let's basically make the ejectors pin, and in order to do that, I'm gonna go and design the ejector pin, and at the end I'm gonna bring basically the model from the library. I'm gonna click on design ejector pin, and I'm gonna make the pin at the back of this model, but the problem for it, I don't necessarily see it well. So in order to do that, what I will do, I prefer to work on the part itself. So I'm gonna hide everything from the back. I'm gonna hide this as well. Yes, so I will see the back model. And what I will do, I click again on the design ejector pin. I get the top view of the model. What is quite important in here, you need to open this one up. Make sure you untick the symbol, because if you use a symbol within NX, usually it doesn't visualize it for you for a better processing. So you don't see it, and we want to see them. Click untick this one and click on specifying the points, and I'm gonna create the points. Let's say the first one I'm gonna make the one here. Click on OK. Every single time you have to click once. Again, another point. But I'm gonna have it, let's say in here. Click OK. I'm gonna have it, let's say here. I can have actually 4. Let's do 1. Okay, I'm gonna do more in here. I'm gonna do 1 more. I'm gonna put it there. Of course, you can put it in the between as well. Let's do 1. Okay, I'm gonna do more. Okay, let's do 2 in here, 1 in here. I'm gonna do 1 in here as well. So until you're confident you have enough points. Once you finish, click on OK. Give it some time, because we're gonna create those ejector pins for you, and you can see this is the ejector pins that it created for you. If you didn't untick the symbol, you won't be able to actually see it, which is quite important here. Now I need to post-process it. So and this is quite an important stage in here. I haven't defined the length in here, which is why that these are short. In order to actually make sure they're long, what I can do, I can basically click on every single of these, and I would be able to actually go and then override that information, because otherwise it won't be long enough to be able to reach to the part. What I will do, I will click on edit tool components, and in here I can see the length, make it longer, so 160. It doesn't matter if it's long, because I can shorten it out later on. Let me do it again. Edit tooling components, 160. Gonna go and click on apply, and you can see everything has been applied in here. This is if the length doesn't meet that dimension. I'm gonna make sure the 160s meet them well. Yes, 160 is fine. Okay, now you can see that actually it's quite long. Now I need to trim it. So what I need to do basically post-processing. What I will do, I'll move from design ejector pin to the post-processing. I'm gonna make sure that we select all of them in here. So I'm gonna select them, because the other part is mirror, so I don't need to select the rest. This one, this one, this one, this one, this one, this one, this one. I don't need to worry about the rest. And what I need to do, I need to select trim, and I need to click OK. So what it does, it's gonna trim them now. With the beauty of that, because we use the dual workpiece, whatever modification you do in one part, it also applies to the other part. So we've also done this part as well. If you want to bring everything back, click on here, show and hide, click on plus, it brings everything back, and you can see the ejector pin are inside, and also they've been trimmed as well. I'm gonna bring the base to the gate and runners. So in order to do that, I'm gonna use a tool called the design fill, and the design fill is this one. The icons keep changing. And within the design fill, I have to find out the area that I'm gonna apply the gate and runner, and in order to do that, I need to first select what type of runner I want to have, and I need to specify the location of them. But I don't see inside, so same as before, I'm gonna get rid of everything else in here. Also, you can isolate as well. It's the isolation you can go with. Here you can actually isolate, and you can concentrate on the core and cavity. If I do that, for instance, I can see isolate. I will just see this one if you think it's easier. Also gonna hide these. I'm gonna hide these. Yeah, I'm gonna go with the design fill. We're gonna bring runner. Let's bring the runner 204. Depends on which one actually what you're looking. I'm gonna use the runner 2 in this case, and with the runner 2, I need to basically give the dimension for this one. I put the point that I want to have it. I'm gonna put the point in the center. I'm gonna click on the point. I'm gonna have it in here, and you can see it's basically bring it in, but I need to rotate it. And also if I see the side view in here, I'm gonna go and look at to the top view to make sure that it's completely, yes, 0 0 0, absolutely right. Now we're gonna go to the side view. You can see it's inside the model. I'm gonna bring it a little bit up, a little bit upward, more, and yes, that should be okay. But in terms of the lens of that, I need to update it. 40 is fine. We can actually even extend this to 45, but you can see, just to show it to you, that you can see I can increase the length, but I gotta put the gate at the end as well. So 40 should be fine. I'm gonna increase the thickness, so to help with the better flow rate, I'm gonna change it to 5, let's say, and the 5 is a little bit in, so I'm gonna bring it up. Again, 5 if you're fine. I think it's a little bit too much. Okay, let's go with the 5, and then I'm gonna click on OK. So we've done this part. Now we're gonna basically bring the runners as well. This is the runner. We're gonna bring the gates as well. So I'm gonna add the gate. Same process. Design field. This time we're gonna go with the gate. Which gate? Let's go and use the gate fan. Location of them. I'm gonna select this one and automatically add it on both sides. Make sure you're into the side view, because I'm gonna make sure that it doesn't, make a relation with the part. You can see now it doesn't fit in, so it's still these 5. And what I will do, I'm gonna bring them a little bit out, Now it's too much, because if you go inside, you put the imprint, or what we call it, a scar. I think it would be good. Then we bring it a little bit up. Whatever you do on one side actually goes up. This one, it can become a little bit. Yes, that's perfect. And in terms of the height, I'm gonna bring it a little bit forward. That's perfect, really good. And click on OK. So we've done this part. That actually hits both area. Yes, really good. Now what I'm gonna now go and then continue with the runner again. And in order to do that, I'm gonna click on runner. From the runner, I need to sketch the runner, but what I need to do, I need to basically see the ring that actually we imported, otherwise I won't be able to use it. So what I'm gonna do, I'm gonna bring everything back in here. I can go with isolations that we work with. I'm gonna bring everything back in here. And there are a few things I don't need. I don't need this one. I don't need this one. I just need to know where it is, so I can basically connect them together. Otherwise, I won't be able to work on that. I'm gonna select and actually bring everything to make sure I didn't hide something. I don't want these. Yes, but I want the other part. I need these hide. I want these components. In here, hold on a second, because I need the location of that comes from the center. What I've noticed in here, we didn't add the bushing in here. Let's actually, I don't know, when I selected it, didn't bring it for myself. I'm gonna go and then bring the bushing as well in here. And I don't know which one should use. This one, let's say. I'm gonna click on OK to bring the bush in. Okay, nice, that will be better. So I'm gonna hide this one. and I'm gonna select the, okay, that's better. I go to the home, new data and plane, and I'm gonna make the bisector plane between this and this, and that become exactly in the center. And what I will do, I'll go back to Mold Wizard quickly. I will select the runner, sketch. I'm gonna select the plane that I just created, which was in this datum plane, and I'll select those. Click OK. And for some reason I didn't pick it up. Wait a second. Okay. And then now what I will do, I'll create a line from here, make sure it's in the center, perpendicular to here. Finish the sketch. And the D of that we discussed about, the first one was 5, so let's go with this one with the same size as well. So we're gonna go with a little bit bigger to help with the better flow rate. I'm gonna make it as a 6, and that's it. Also, if you want, you can get rid of these plane and then hide it, by the way. So we've done this part as well. And now if I go to here, if I go to the top, click everything back, go to the show, you'll be able to actually see everything back, and also make sure that nothing is hidden or is basically isolated in here. What I will do, I'll also select this one and double click, so everything's back and everything is in place. And if you have a look at it in here, you will see the runners that actually inside are also going through these as well. So I've done this part. So gate and runner is been done. Now I need to basically make the cooling channels. For the cooling channel, what I need to do, and again, it should have a sketch, and then we'll convert it to the cooling channels. What I will do, I will select, before actually we'll go that, I'm gonna make the creating that channels first, and I'm gonna select this one. Click on to the pattern channel here. I will click on to the sketch. I'm gonna get a basically cooling channel in between the workpiece. So I'm gonna make a reference plane. Let's say this one, I'm gonna change it to the at distance. I'm gonna make sure it's at distance. With these, I'm gonna see how much I need to bring it down, basically. See whether it's, we need to move it. Yeah, -15, I think it would be good. Closer to the model is a little bit better in here. So I'm going to click on OK. This one I'm going to put it on the XZ, and I'm going to specify a point if I can find a point in here. But it's quite important, check again to make sure that you have a correct plane. Otherwise, it won't be able to pick it up. Everything's fine. I'm going to click OK. I'm going to make a rectangle in here. I'm going to put the dimensions, and this one, let's say 140. Don't remember the dimension for the workpiece. I can actually check it in here. If I go to analysis, I can measure 170 minus 140 and divided by 215. So we'll go here and say from here to this side. If in case you don't pick it up, the side doesn't matter, don't panic. Click both. Now you would be able to see this line. I'm gonna select 15. I'm gonna change this one also to 15, and this size, let's do it as 70, for instance. No, 70 is too much. Okay. Now I need to repeat the same process for the other part. What I'm gonna do, I'm gonna then use mirror, right? Then I basically repeat everything to just save time, and then I'm gonna select the curve that I want to mirror across on the XZ mirror, click OK, and if I click on finish, you'll see the cooling channels has been created for me. The diameter of that, I'm gonna keep it 1010 for now. So I'm going to click on OK. Put in the basically the trimetric view. And now what we're going to do, basically we're going to create the inlet and outlet as well. So what I need to do, I need to extend the channels. What I will do, I will basically click on first extending channels before we define them. I'm going to go extend channels. I'm going to select the area that I want to extend. Let's say extend this one, and the value of that extension, let's say 20. Apply. I'm gonna extend this one 20. Gonna extend let's extend this one first. I think that would be better to do it, so we'll have similar. Yes, so let's do the inlet from here into the opposite directions that I want. So I want the basically, let me unselect it. I'm gonna select this one, apply. I'm gonna select this one, apply. That's better. So we extended. Now let's define them in here. So what I will do, I'll basically go and then define the channels. So from the channels, I have to say what I want to define. I'm gonna select the material I'm gonna have. I'm gonna put water into it. I'm gonna select everything. But of course, you're gonna see what coolants you're gonna use in here. I'm gonna click OK. So you add water. That's why it become blue. So what else? I'm gonna basically make a circuit in here. So what I will do, I'll basically go and see the circuits. This one, I guess. Yes, cooling circuits. So I have to clearly clarify where is the inlet, where is the outlet, and so on. So I'm gonna select this area. So let's say the air comes in. The water comes in, go there, goes out. I will do the same thing in here. I'm gonna do apply, and for a second circuit, I'm gonna say comes in, go in, and then go out, and then I'm gonna click on OK. So we defined these as well, and we're gonna bring also the rest of the components for the cooling channels. So we'll bring them from here. I'm gonna select everything in here, holding shift and click on apply. It automatically applies because it knows where is the inlet, where is the outlet. And click OK. I don't know what, for some reason I actually didn't add to the top part of these. Bear me a second to actually go straight to why it didn't pick it up. If we define the cooling channel correctly, I think, yeah, this is the circuit 2. Didn't come out. Yes, for circuit 2 I didn't complete the circuit 2, which is why it didn't work. I'm gonna bring it in here. I'm gonna make sure that I update the rest. The beauty of the Mold Wizard, everything is updatable. You can come back and also adjust it. So basically we're done. If I go and go back to the top level in here, I bring the model. I'm gonna make sure that I will show everything. We are done. We have runners, we have the gates, we have the cooling channels. We basically cut the ejectors pin, and we are done. So what we have some basically parts actually they are intersecting with other parts. So we have to do a pocketing. And with the pocketing to be able to do, click on the pocketing, and I'm gonna select the everything basically. Select all, or do a Control A, again Control A, and then click on apply. You should be able to pocket everything. Sometimes you get error, sometimes you don't. I think it's doing it for the majority of the parts. Let's see how it goes further. Yes, that should be fine. Yes, the pocketing has been done as well. So you can see these parts actually they've been cut. So in order to let's do another motion simulation, but this time of course we have more components. I'm gonna go with the motion simulation that we created for before. You can see that you have these components. You can see the really nice cut for the cooling channels as well. But so what we said, these components on the workspace, they're moving. This one is the basically fixed, what I can do, I can go to add components, mount components. For the fixed part, moving part was the bottom, fixed part was the top. For the fixed part, what I will do, I will also add more things. So I will add this one, I will add this one, and let's bring this one as well. Just mount them to have a look at it first, and then we'll keep completing it. Let's play it. Really nice. So I'm gonna go and continue with the fixed one. The fixed one, even this component, this component, this component, this would be fixed. For movable ones is this one, this one, this one, this one, this one. Of course, you know, once you have it more complete, it's better. I'm gonna mount them, click OK, and then I'm gonna put it to the side view, zoom out a little bit so you will see it better. And you can see the simulation. Let's have a look at the simulation. So this is basically, we've done a simulation, but of course, you know, at your own time, you can go back and then make sure that you include everything for these as well. I don't know what other elements is missing in here. For instance, this one is missing, mount, and then you can see it. So that was it for today. Hopefully you get through these at your own time to actually understand the process better and practice at your own time, and hopefully you enjoyed what we've done for today. Please let me know if in case you have any questions. For the final note before we finish the this tutorial, in order to get the bill of materials, you can click on the bill of materials in here, and if you select the bodies, I'm gonna select everything. I'll do a Control A and do here, select bodies. It basically give you every single component that we had. Also, you can export it to the Excel, and it should automatically comes with the material, with the bill of material, with the part list, and so on. Thank you so much, and hopefully to see you another time. Thank you. Bye bye.